Hello everybody, this is Rudra Pradhan here and welcome you all to BMD lecture series. Today we will continue the new component called as predictive analytics. In the predictive analytics we have three parts: predictive analytics 1, predictive analytics 2 and predictive analytics 3. And in the last couple of lectures we have already discussed various issues relating to business analytics. That too we have discussed descriptive analytics and inferential analytics 1 and inferential analytics 2. And all these analytics, the descriptive analytics and inferential analytics, that is the part 1 and part 2, are very useful, or in fact it is a more or less compulsory for this particular predictive analytics. Without knowing the descriptive analytics and inferential analytics, it is very difficult to understand the concept predictive analytics. So, so my suggestion is you must have actually enough knowledge or enough exposure on the basis of descriptive analytics and the inferential analytics, and then we will come down to predictive analytics. And in fact, in the business analytics, predictive analytics tool is a kind of key component. So, through this predictive analytics we can go for prescriptive analytics, and for the predictive analytics we need to have a connection with the descriptive analytics and inferential analytics. So, now in this particular predictive analytics, particularly the part 1, part 2 and part 3, we will discuss various issues, business related problems, and dealing with the kind of prediction and forecastings, and then we are in a position to know certain the decision making process through which you can solve some of the business problems. And let us see what are these concepts behind predictive analytics and how will you proceed, and what are the techniques through which you can solve the business problems and coming for a kind of management decisions. And the objective of this particular unit is like this: understanding the concept of association in business analytics, knowing the fundamentals of regression analysis and its application in predictive analytics, then understanding various requirements in regression model building and assumptions of regression models, and knowing the interpretation of regression results for management decisions, knowing the regression model diagnostics for predictive analytics. So, these are the broad objectives for this unit, and the unit highlights are like this. So, we will start with simple regression structure, then we will connect with multiple regression, and then we will be dealing with statistical inference on parameters connecting to regression analysis. Then we will know coefficient of determination, analysis of variance, then we will address regression model with various diagnostics issues like multicollinearity, autocorrelation and heteroscedasticity. Besides, we will be dealing with several other predictive analytics tools. So, in this particular units we will be dealing all these components. So, let us start with the simple regression analysis. So, in the predictive analytics, regression analysis is one of the most important techniques, and since many business prediction problems are modeled by using this particular technique, and regression analysis is one of the supervising learning algorithms. That is a particular regression model requires the knowledge of both dependent and independent variable in the training data set. So, in the couple of weeks back we have discussed the concept of associations, and in that case we have discussed the issues about the covariance and correlation, and here we are dealing with the concept called as regressions, and in fact we have already discussed the concept called as correlation. And before correlations, the association technique is called as covariance, and then it will be followed by correlations, and both covariance and correlations can give you the kind of degree of association between two and more variables. However, it will not give you the kind of the causality part, which one is the cause and which one is the effect, and after knowing the cause and effect, then we are in a position to predict as per the kind of problem requirement. So, regression analysis is a kind of what we call as dependence technique, through which some of the prediction can be done with the help of the kind of independent variables. In fact, in the last couple of lectures we have discussed about the understanding about the variables, and there we have classified variables into two parts, dependent variable and independent variables. So, as a result, we have a kind of different clusters of analytics tools, where we need to know the dependent structure and independent structure, as that will help you to predict the kind of things. In fact, the kind of structure is okay. So, the business analytics, particularly for predictive analytics, and that to the so far as association structure is concerned. So, we have actually two groups of techniques. So, basically the techniques can be divided into two parts. One is called as dependence technique, and the another is called as interdependence techniques. Okay. So, in the case of dependence techniques, so we need to have a classification about the dependent variables and the independent variable. In the case of interdependence technique, most of the variables are seems to be interdependent to each others. Under dependence technique, so one particular tool is nothing but called as regression analysis. So, we will be dealing with now the regression analysis, but in the analytics baskets, particularly the kind of association techniques, we have a plenty of techniques, but one of the most important technique which will be very useful for most of the business related problem is nothing but called as regression analysis. So, we will be dealing this particular concept, and this lecture will give you some kind of snapshot about the concept of regression analysis, how to start the particular process, how to connect with the problems, and what are the process through which you can predict the kind of business requirement, and then accordingly we can come for some kind of management decisions. Let us see how is the particular structures, and then we will follow up a particular problem. So, so that we can address the business problems as per the requirement. And typically in this lectures, I will highlight the bivariate structure of regression modeling. Then I will connect with some problems, and then I will take you to the data analysis, that is a spreadsheet, to highlight how the particular prediction can be happened if you have a problems, and the relating to that problems you may have actually data. So, having problems and having data, so you can use actually kind of spreadsheet, and then you can do the kind of predictive analytics, and that too through regression analysis. This is what the summary of this particular lectures. Let us see how is the kind of concept. Okay. So, okay. So, so this is how the background about the regression structure. So, it is the process of constructing a mathematical model or a function that can be used to predict or to determine one variable by another variables. That is what the structure of dependence technique. So, that means here we are trying to predicting the usual structure called as dependent variable, and that too with the help of independent variables. Correlation is a measure of the degree of associations of two and more variables, and compared to regression analysis. So, this is not so, means correlation is not so effective to predict useful for kind of predictions, but regression is the useful technique which can be very useful for kind of prediction. So, when we are dealing with regression problems relating to regression analysis, by default correlation will be there in by the process, right. So, let us see how is this concept and how correlations and regression can work together. And in fact, in the bivariate analysis, particularly bivariate regression, so the summary of the regression output can be represented through also correlation analysis. So, I will show you the typical structure. So, that means typically the understanding of regressions highly depends upon the understanding of the correlation. If you do not understand the correlation, then you may not in a position to understand the regression. So, by the way, so for the business requirement for making management decisions, so you need to know these techniques and then connect the problems as per the particular requirement. So, before we proceed actually, so here is the kind of requirement. The requirement is okay. So, it is a kind of so let us I will give you kind of connections. So, what are the areas through which you can actually apply business analytics? It means that to this simple regression analysis. So, in many business organizations there is a the performance measures which you call as KPIs, key performance indicators. So, like cost of goods and services, return on an investment, efficiency, productivity, sales growth, profits, and these are the indicators through which we can measure the performance of a particular company, and we can do the prediction as per the company's requirement or organization's requirement. In this case, regression in the kind of prediction of organizational performance or industry performance. So, we have to use these key indicators, that is the KPIs, and in fact, most of the instances. So, KPIs are influenced by several factors. These are the factors which we treated as independent variables. So, what we like to know, or the regression will help you to know how these independence variable are linked with the KPI, that is the dependent variable indicators or predictive indicators. So, now once you know the kind of structure, the kind of strength, then we are in a position to predict the kind of business performance or organizational performance. So, this is a simple examples where regression can be very effectively used for some kind of requirement of management decisions. So, now I will take you to the kind of structure of the regression analysis. So, we will be starting with simple one, then we will go. That means, technically regression can be structured into three different formats. So, the bivariate, that is what the structure called as a simple one, then trivariate, and then we try to go for some kind of structure called as a multivariate. Under multivariate, so we will have some kind of multiple regressions. Then actually there is a multivariate where there may be many dependent variables along with many independent variables. So, now these are all the kind of complexity, but we need to know the simple one first, then we will move slightly slowly towards the complexity, but more or less if your simple understanding is very clear, then you can follow up the complex one. And simple in the simple regression analysis, so it will be dealing with two variables, and that too, one is the dependent variables and the another one is the independent variable. It is the game between a predictant and predictors, or explained explanatory. So, so this is the kind of structures through which you have to discuss. And before we start the process for any any kind of problems, we need actually management decision, and that to use of regression. So, regression has some kind of requirements, or in this particular predictive tools, in this particular predictive tool cannot be used each and every problems. It will be applied in a kind of environment where minimum requirement it should be filled up. So, these are the minimum requirements you must have before you go for some kind of using the regression analysis for kind of business prediction. And first things, must have a problem with at least two variables, and if it is only one variable, then this technique cannot be used. Then second one, must know the dependent variable and independent variables, and then sample size for all variables must be uniform. For instance, for the simple regressions you need two variables, and if there are two variables, then corresponding to these two variables you must have a sample point, and that sample point must be uniform. That means, technically if x is a variable having 10 points, then y must have a variable 10 points. If one is having 10 points, another is having 15 points, or vice versa, then you may not be in a position to run the regressions. Sometimes there may be the case that you have 10 observation or 15 observation, then through some interpolation and extrapolation you have to fill up the gap and then bring the uniformity. After that you can apply the regression, and again sample size must be strong enough to contrast to number of variables in a particular business analytics problem, and must have theoretical and logical understanding about the relationship between this dependent variable and independent variable. And then you must have go for data visualization before you start the process of predictions. So that means this there you have to set a hypothesis with respect to the problems. So that to the hypothesis theoretical hypothesis will be like this, that you have to predict the sales, or you have to predict the profit, or you have to predict the return on investment, then subject to identification of the independent variables, means the factor which can affect these key performance indicators. And in that case how they can be actually modeled means sometimes a model means it is a kind of functional relationship between the dependent variable and independent variable. But here until unless you know the particular structures, that is the visualization part, then you may not build the model perfectly. For instance, the functional relationship depends upon the kind of visualization of the data. So there may be chance that the model can be linear one, the model can be non-linear one. So that's why the visualization will give you kind of perfect path through which you can go for perfect predictions. So this is what the basic requirements of the regression analysis, and with this we can move to this particular process. And then though I have theoretically highlighted what are the areas through which you can apply the kind of regression analysis, and that to the kind of predictive analytics. And here the cited example, this is the live example of a kind of airline cost data, and here there are two variables. The first variable is the number of passengers, that is represented by x, and the second variable is the cost, represented by y. So mathematically y is usually recognized as a dependent variable and x is recognized as an independent variable, but there is no hard and fast rules. But we will start with the process that y is every time dependent variable and x is the independent variable. So that means here actually we have actually series of data points here. So this is actually the independent variable informations, and this is the dependent variable informations. What I have already mentioned, that you must have uniform data points for both x and y. So you have actually whatever data points are there, the same data points are also here. So that means it is actually the first hand requirement is satisfied, and the second hand requirement is here, the sample size should be greater enough to variable size. Since there are two variables and we have actually more than two observations, so that means the necessary condition is satisfied. But actually means in the kind of predictive kind of structures. So we represented by the sample information say n, and the k is the number of variables. So this is actually sample size and this is the number of variables, and usually the structure is n greater than 2k. But that is the necessary condition, but the sufficient condition depends upon the number of variables and the kind of particular requirement of data points. Usually we have a small sample and large samples, and we have already discussed in the case of inferential analytics, and that part we will take care here while dealing with the problems and the kind of predictions. So let us see the game how we can proceed further to know these particular tools and to predict this. So that means in this problem our job is to predict the cost subject to number of passengers. So now how will we do for the kind of how we can use the predictive analytics that to the use of regression analysis. So here as per the requirement we will go for data visualizations, and in this case so here the x axis is the number of passengers and the y axis is the cost, and the plotting is coming like this. And accordingly, so you can actually get to know that there is some kind of linkage or the kind of movement. So having the kind of slight hint from the data visualization, and then we have actually theoretical knowledge that cost and passengers, so that is actually customers are having actually correlated, and then we like to know how passengers can help you to predict the cost structures. So actually the theoretically that increase the passengers may increase the cost, but we like to know the quantitative pictures or the quantitative amount or quantitative numbers through which you can do the perfect prediction. So, that is how the regression analysis can be applied and can be used for this particular quantifications. So, now moving forward, so we will see here that the basic regression models can be written like this. So, we are every time we are dealing with the sample problem and then give the comment about the populations. So, the same structure we can have here. So, having the sample data, you can actually build a models and then you can predict for the population. That means it's a kind of generalization, and it can be a probabilistic form and it can be the deterministic forms. In the case of probabilistic, so the structure error term will be there in the system, and in the case of deterministics, so there will be no error terms. And so here y is the dependent variable, x is the independent variable, and beta 0 beta 1 are the parameters, and that need to, that's the population parameter, and that need to be actually estimated for the kind of predictive requirements. And beta 0 beta 1 are estimated by the sample statistics and followed by small b 0 and small b 1. So, having the sample information between these two variables, so we have to estimate the particular equation and then get the estimated outputs, and that is what the regression output, and on the basis of regression output we can go for some kind of predictions. So, let us see how we can move further, and this is the usual structure of estimated equation. So, we will be dealing with it previously. So, this is the equation which you are going to estimate with the sample informations, and then we will follow here the estimations. After the estimation, the error terms by default will be removed, and the final equation will be y estimated will be beta 0 plus beta 1 x, that is actually sample intercept and the slope slope coefficient, and then we have to predict the y corresponding to the particular x availability. So, now so the first hand requirement or regression will be you are supposed to know the tools to how these parameters can be obtained from the sample data. So, these are the indicators through which you can do the predictions. So, in fact, we have already discussed demand predictions, sales predictions in the first unit of this particular lecture series, but now we are going in depth actually get to know how these are all coming all together. So, this regression will help you to know the in-depth understanding and the kind of inference, exact inference as per the particular requirement. So, now having knowing the particular structure, so we can actually move further, and then okay. So, now we actually the particular process is so this is actually the kind of this is the model, estimated model, and then what we need to do actually to get these parameters, we like to find out the error terms, which is the difference between the actual values of the dependent variable and the estimated values of the dependent variable. So, that means technically, so we have actually we need to calculate E, that is error component, which is the difference between y minus y hat. So, the y is the actual value and the y hat is the estimated value, and estimated value will be derived from this particular equations, and then the difference will help you to get the kind of error component. Now, what will you do actually? So, we have actually some of the tools, like one of the tool is ordinary least squares. So, we like to apply ordinary least squares to minimize this error sum squares. In the way you will minimize the error sum square, then by default you will get the values of these parameters. So, that means technically what we like to do. So, we will square both these sides and then we will take summation. So, technically summation E square equal to summation y minus b 0 minus b 1 x, and that 2 squares, and then what will you do, since our requirement is b 0 and b 1. So, we have to minimize with respect to d summation E square by d beta 0 d b 0 equal to 0 and d summation E squares by d b 1s equal to 0. So, now once you simplify, then you will get two different equations depending upon these two variables or two parameters, and the solving these two equation with the help of data, by default you will get the values of these parameters. So, in the next slides I will let you know how these are all coming. Okay. So, this is how the once you simplify the particular structure, then ultimately you will get beta b1 coefficient, that is actually covariance of x y by variance of x, and this is on the basis of the previous simplification, that is with respect to d summation E square by d beta 0 b 0 and d summation E square by d b 1s. Then once you simplify, then the first end value you will get this ones, that is the actually b 1 coefficient. Now, the second one is the b 0 equal to y bar minus b 1 x bar. So, technically, so you will find summation y equal to means technically. So, what will you do? So, let me give you the idea. Actually, it is nothing but actually E equal to summation E square equal to summation y minus y head whole square, that is nothing but summation y minus b 0 minus b 1 x whole square. So, now if you simplify, then then you will get two different equations. So, in the first equations we will follow the particular structure, then the second equation will follow the b 1 structures. So, then after doing all these things, so automatically you will get the beta 0 coefficient and beta 1 coefficients. So, I am not going in the derivations, but ultimately once you simplify with respect to beta 0 b 0 and b 1, then by default you will get b 1 coefficient and b 0 coefficients. So, now b 1 coefficient and b 0 coefficient will help you to predict the particular y value subject to availability of x value. So, let us see here. So, how is the particular structure, then accordingly. So, if you will again simplify, so it will be coming actually b 1 equal to s s x y sum of square, that is actually covariance. That means technically, so the structure will be like this. So, we have actually x y, and then if you prepare the covariance matrix, so it will be, so this is x x and this is x y, this is y x and this is actually y y. So, now with the help of this covariance matrix we can in a position to calculate these values, and accordingly you can also get the values of the b 0 coefficients. So, in the next slides I will let you know how these are all coming in a kind of a systematic process. So, let us see the kind of structure. Okay. Okay. So, let us see here. So, this is actually as per our problem structure. So, we have actually x information and we have y informations, and our job is to find out y predictions, right. So, which is nothing but actually b 0 plus b 1 x, and that to number of passengers, and that means technically cost is a function of actually the number of passengers. So, now as per our requirement, so you need to have actually, so first b 1, so that is actually the n summation x y minus sum x into sum y divided by n summation x y minus sum x sum x whole squares. So, this is actually b 1 coefficient, and b 0 equal to y bar minus b 1 x bars, right, b 1 cap, and these are all actually estimated, and so that means technically covariance of x by variance of x. So, now for that actually, so you need actually x square and then x y. So, after knowing this, so automatically you can get the kind of values. So, it is technically n summation x y minus sum of x square. So, this will be the kind of structuring. So, let me give you another way in the clean copy. So, this is actually the beta 1 coefficient, that is covariance of x y by variance of x, and then beta 0 equal to y bar minus B1 head x bar, right. So, this is also kept and this is also kept, and the first hand requirement is covariance. So, for that you need actually x y, and then variance of x you need actually x squares. So, now having this information, so first you find out the B1 value, and with the help of B1 value you can find out the B0 value. So, that means actually this is y bar. So, that means it is the sum of y divided by sample observation, that is n, and similarly x bar, that is summation x by n, that is x bar of this x series. So, after knowing the B1, then you can easily get the B0. So, that is how the model requirement. So, once you have these model requirements, then you can move for estimation or kind of prediction. And so, this is how the kind of simplification results. So, on the basis of so we need actually the lower part of these values. So, sum of x, sum of y, sum of x square, sum of x y, and then you go to this structures. So, here is actually the requirement. So, SS x y, that is variance of x y, covariance of x y, and that is how it is coming here. Actually 68.745. Then this is variance of x, and by default your B1 coefficient will be covariance of x y by variance of x, and it is coming actually 0.041, right. And B0 coefficient is coming actually y bar minus B1 x bar, and that is coming actually 1.57. As a result, your estimated equation will be y cap equal to 1.57 and plus 0.0407 x, right. So, this is how the kind of estimated equation, and this is what the B0 and this is what the B1s, right. So, now this earlier our functional form is B0 plus B1 x. So, now the model will be y equal to 1.57 plus 0.041 x, right. So, that means, so by default B0 is this much and B1 is this much. So, this is these are all unknown parameters. Now, these are all known parameters, and that is obtained with the help of sample information, the past availability of data, or the kind of the problem structure. So, once you are connecting with data and the models, so the estimated output will give you the kind of known values. On the basis of these known values, you are in a position to go for some kind of prediction. That too, in this case we are predicting the airline cost subject to the number of passengers. And in the case of further about this particular technique, so what we can do actually, so we like to check how is the particular modeling, right. So, that means technically, so we have actually here y and we have actually x, then we will get y predicted and the a. So, technically if you go to the Excel spreadsheet, so the original problem boundary will be like this, and then with the help of this estimation, so we can get the y hat series, and then y minus y hat series you will get the E series, right. So, now what is happening here? So, number of passenger here is in actually x axis and the cost is in y axis, that is what we need actually prediction. And as a result, so corresponding to a number of passenger one point to another point, so we have actually cost structure from one point to another point. So, as a result, so the kind of these points are actual points, all these all these points are actual these are all called as actual points, that is with respect to number of passengers and number of and the cost structure. But the line, straight line, is nothing but called as a predicted line, and now if we join all these points, then the curve will be coming like this, and this curve is nothing but called as a y actual, and the straight line, that is the predictive line, is nothing but called as a y head. Now, for every point, for every passengers, let us say 60. So, for when x equal to 60, for instance x, y and y head, right. So, now for x equal to 60, so you have a y information and we have a y head information. Similarly, when it is 80, so you have y information and y head information. Then now the difference between the two will give you the error terms, right, like E1 and E2. So what we like to check finally, that how is the position of this particular predicted line. So usually the regression line, this is called as regression line, and otherwise it's called as average line. So the line by default, of course by mathematical process we are getting this particular line, but so far as a validation is concerned, so the line can be, the line looks like 45-degree angle, so it can be further up or further downs, but the thing is that so whether this line is perfect or not, so we have a lots of checks, on the basis of these checks you can find out the kind of or you can justify that this line is perfect for the kind of prediction or the kind of requirement. So one of the cross check is nothing but the error sum should be equal to 0. So if you will find the sum error sum is coming actually 0, so that means actually when you draw the predicted line, then some of the actual points will go up and some of the points actual points will go down. So then what is the how will you judge that this line will be best fitted line. So that means the sum of the upper points must be equal to sum of the lower points corresponding to the estimated, that is the regression line, the estimated regression line. So if that is the case, then we can say that this model can be, means there is a reliability, or there is a kind of accuracy through which you can do the predictions. Of course there are lots of other diagnostic checks, but this is the first hand kind of inspection through which you can do the kind of predictions as per the kind of problem requirement. And accordingly, so we can move further, and so this is actually the kind of overall regression output. So on the basis of the y information and x informations, so you can actually find out the entire regression output, and the regression output will help you for the y prediction corresponding to x availability or x informations. So in the next lectures I will take this problem to the spreadsheet, and then I will show you how these outputs, regression outputs are actually coming. And now in this output you will find there are plenty of informations, and there is a box here like ANOVA, and which we have already discussed, and then these are all called as regression outputs, that is estimated on the basis of y and x. So in fact we till now we only know how to get the coefficients of b0 and coefficients of b1, right. But in this particular process we have actually lots of other informations, why these informations are there and how they how these are all coming in the regression, what is the utility of these informations, and how these information can be helpful for this predictive analytics, that we will discuss in details in the next lecture. So with this we will stop here. Thank you very much. Have a nice time.